Let's go back to model evaluation now. We see an accuracy of 94.62%. Go to the last tab again. Accuracy of 94.62%, meaning a corresponding classification error of 5.38%. That is, the model has got only 5.38% of its overall predictions wrong. Click on model evaluation. This type of view is called a confusion matrix. It's a 2 by 2 matrix where we compare the actual and predicted values. So you can see from here, the model has predicted 7 values incorrectly. That is, in 4 cases, the model has predicted M, but it is actually B. In 3 cases, the model has predicted B, but it is actually M. Okay. Now let's look at precision and recall. So we have something called class precision and class recall provided. Class indicates malignant or benign. So let's look at the precision and recall for malignant. Okay, the model is predicted malignant 50 times and it has been right 46 times. Okay, so from here I am talking about this. 50 times it is predicted as malignant and it has been right 46 times. So the precision would be 46 by 50, which is 92%. And similarly, out of the 49 malignant cases in the data set, it has predicted 46 correctly. So the recall would be 46 by 49, which is 93.88%. Okay, so now let's look at the decision tree visualization. Okay, note here that though there are 32 columns in the data set, the model has used only 5 columns. It has used just 5 variables to classify the complete data as malignant or benign. Now, if the perimeter worst is greater than 117.45, 100% of the data is malignant. If it is less than 117.45 and concave points worst is greater than 0.176, again 100% of the data is malignant. So similar splitting of the tree goes on till all the data points are classified. So you can see that in only one node there are both malignant and benign data. 1 benign and 4 malignant. As we have seen in the theory part, when a new observation is classified, the class of the majority value is assigned to the observation. So any record that meets this condition will be classified as malignant. This condition meaning, so here greater than, less than, greater than, you come to this node. Once it comes to this node, it will be classified as malignant. Okay, now please note that this visualization tree is built on 90% of the data from the data set which we have uploaded. Look at this, there are 122 items here and there are 288 items here, 288, 122, 410 items out of the 455 we uploaded. So tree has been built on 410 items only. Okay, so the rules are learned using these 410 records. Now when a new data comes in, the same rules learned here are applied to classify them as malignant or benign. Also, you should be able to see from here, the model evaluation is done on a random set of 130 rows from the data we have uploaded. Okay, so you may see some difference with the numbers I am showing here, since the data is a random split. So you may not have the same 130 records in your test data set, but more or less the number should be same. Okay, what we'll do now is we'll make the predictions for the test data set which we have created earlier. So accuracy should be slightly less for this data since none of this data was used in the model building. We'll call this unseen data. Okay, to do this, you go and click on apply model, apply a new data set. This is a model name which we have just created. And data. The test data set. Calculate predictions. So now the rules learned by the model using these 410 records are applied on this test data set, which is we have around 114 records, I guess. So these records will be classified as either malignant or benign based on the rules it has learned. So now we'll compare the actual and predicted value for this test data set. Okay, so what we'll do is we'll simply export this to an Excel. Okay, so this column is the actual diagnosis and this is the predicted diagnosis. So we'll compare actual and predicted values to see how the model has performed on this test data. We'll do this by building our own confusion matrix by using a pivot table. Insert pivot table. Actual diagnosis on the row, predicted on the column, and the count of some variable as a value. Let me rename this as actual and this as predicted. Okay, the model has predicted one actually benign record as malignant and it has predicted 6 malignant record as benign. So this is the problem case for us. 6 malignant cases have been diagnosed as benign by the model. So this is what we would like to avoid. So we will see if we can improve upon the model performance in terms of malignant prediction in the next video.